Good morning. Am I audible? Oh, Priyank, Jeet, Sanish. So we continue with non-deterministic finite automata. In the previous lecture, we had studied that we can convert any NFA to deterministic finite automata. The theorem we proved, examples we worked out. Now, let us look at these examples. A. NFA accepting 0, 1 star. The language is 0, 1 star. So initial state is Q0, that is 0. And because it is star, 1 star, so in the accepting state Q1, there is a loop. That is 0, 1 star, figure A. Figure B is NFA for 0 star 1, that is a 0 star. So in the initial state P0, there is a loop, 0 star. Star means 0 or more occurrence, so it could be 0 occurrence as well. So that is P0, that is 0 star, ending with 1. 1 is compulsory. So P0 to P1, 1. P1 is the accepting state. In the first case, 0 is compulsory. In figure A, 0, 1 star. So 0 is compulsory. So Q0 to Q1 on 0, which is compulsory, and then any number of ones. In the second figure, it is any number of zeros, but there must be single one ending with 1. Figure C, NFA for 0, 1 star, 0 star 1. It is 0, 1 star, 0 star 1. So we do in the figure U, that is 0, 1 star Q0 Q1, that is 0, 1 star P0 P1, that is 0 star 1, and we try to combine that. I mean, we need to transitions between Q1 to P0, we have to connect them, and we can connect by putting 0 between Q1 to P0. So even that one which is specified extra, there is no need to write that, that is covered. Having defined a transition between Q1 to P1, that is covered. So it is whatever is visible in this reddish background, so that is there. That one extra one that may be avoided, that's fine. So Q0 to Q1, 0, 1 star, P0 to P1, that is 0 star 1, and we have put a transition because we have to combine this, we have to connect this. We are defining in NFA for accepting the language 0, 1 star, then concatenation 0 star 1. So just to ensure that all the valid strings of 0, 1 star, 0 star 1 is accepted, all the valid strings are accepted. So we are putting a 0 connection between Q1 to P0 and Q1 to P1. We are connecting because see in the language 0, 1 star dot 0 star 1. If you look at that RE, then 0, 1 is 0, 1 belongs to the language. We must accept 0, 1. We can eliminate 1 star in the RE. We can eliminate 0 star from the RE. 0, 1 belongs to the language. So Q0 to Q1, that is 0. Q0 to Q1, that is 0. And then Q1 to P1, we are putting a connection through 1. So 0, 1 is acceptable. 0, 1 is acceptable. So for accepting a string such as 0, 1, we are adding a transition between Q1 to P1, that is 0, 1. Now, let us take an example of a string such as 0, 0, 1. 0, 0, 1. If you look at the RE, 0, 1 star, 0 star 1, then string such as 0, 0, 1, that also belongs to the language. So to accept string of the form 0, 0, 1, we are putting a transition between Q1 to P0 on 0, and then so it will accept 0, 0, 1. Q0, Q1, P0, P1, it will accept 0, 0, 1. We are putting a transition between Q1 to P0 on 0. Maybe something like 0, 000, 1. One more 0. So for additional zeros, it is taken care in the state P0. For example, 0001, 0001. So it is 00, Q0, Q1, P0, that will take care of 00. Then any more 0 that is handled in state P0, and then 1. So that completes the final one. That completes our NFA for accepting the language 01 star 0 star 1. The thing which is there in black color, that can be eliminated, doesn't matter. Now let us look at the fourth figure, accepting the language that is union of our L1 and L2. L1 is our 01 star, L2 is 0 star 1. Union of L1, L2, we are constructing NFA for accepting that 01 star 0 star 1. So again, we know this is initial 01 star, already we have constructed that. 0 star 1, we have already constructed that. And then union. So union is, if a string belongs to either L1 or L2, it should be part of the language. It is L1 union L2. So we connect Q0, P0. Again, we look at various combinations. We are connecting Q0, P0. Also, we have connected Q0, P1. Because as per the RE, 01 star union 0 star 1, only one belongs to the language. Look at this RE, right corner, 01 star union 0 star 1. So in the second RE, from the second RE, there is no need to have any 0. 0 star 1. If my string is only 1, then that belongs to the language. So if I don't connect, this is my 01 star, and bottom part is 0 star 1. So to accept only 1, we are connecting Q0 and P1 to accept 1. 1 belongs to the language. Similarly, if you look at the language L2, it is L1 union L2. Once again in L2, we must accept a string of the form 001. 001 has to be accepted. So we are putting a link between Q0 to P0 on 0. Now it will accept 001, 0001, 401, etc. So we're adding a link between Q0 to P0 on 0. Also, we are adding a link between Q0 to P1 on 1, and that will take care of L1 union L2, 01 star union 0 star 1. That is my final figure D. So we started with the basic languages, L1, L2, figure A and B respectively. NFA for accepting L1, L2, we constructed, and then we went to the concatenation, L1 dot L2. Again, after analyzing the strings that should be there in L1, L2, we appropriately added transitions from Q1 to P0 and Q1 to P1. And then we took the case of L1 union L2, and again, we added the transitions. Priyank, let me answer your question just a minute. And then we added the transitions. What are you asking? Union defines OR. Yeah, that is OR, yeah. Either L1 or L2. Either L1, if the string belongs to L1 or L2, it should be accepted. Now, what we are trying to show, it is not how to construct these NFAs. What we are trying by these examples, we are not looking at, we are not learning how to construct NFA. That we know anyway. The thing is, when we take concatenation or union, we need to do analysis. See, a lot of things we needed to do to construct NFA for accepting L1, L2. No, we found out whether Q1 to P0 only 0 is sufficient, whether 1 is required or not. Then Q1 to P1, we need to add a transition. Similarly, for accepting L1 union L2, again, we needed to work out the strings that should be accepted, and then accordingly we define transitions between Q0 to P1, and again a transition from Q0 to P0 on 0. So we have to analyze and then appropriately put the connections. So that is required. So there is some complications involved when we either take the concatenation or perform operations such as union. from existing NFAs accepting given regular language. Now, what if we can do something like this? So we illustrated the complexity that is involved through these examples. Now let's look at these things. Suppose I am permitted to do something like this: 0 1 star, that is Q0 to Q1. The second part is 0 star 1, P0 to P1, and then I don't need to analyze anything, unlike the previous case. Unlike the previous case, here I needed to check out so which transitions are required to be added. I need to ensure that all the strings are accepted. I also need to ensure that a string that is not part of L1, L2 should not be accepted. So that kind of analysis is required. Now, instead of that, suppose somehow I can just put these blocks, block 1, block 2, and then between Q1 to P0, I put null, that's it. Only null between Q1 to P0, no further analysis. Suppose it can be done like this. And similarly, in the case of union, NFA accepting 0 1 star union 0 star 1, again, I have put block for L1, that is my upper block, L2, my lower block, and then I add a state, leftmost, without any label. And I define a null transition to Q0. I also define a null transition to P0. And if this version of NFA, if it can accept L1 union L2, similarly, if this can accept L1 L2, then my process of constructing NFA becomes very simple. I don't need to do analysis. Now, I don't need to find out the strings that should be accepted, strings that should be rejected, as we did in figure D and figure C respectively for concatenation and union. Instead of that, what we have done in the case of concatenation, put a null transition between Q1 to P0. In the case of union, we added a state and defined null transitions to the initial state of M1 and M2 respectively. M1 accepts L1, M2 is for accepting L2. So added a state and defined a null transition to the initial state of M1 and then null transition to the initial state of M2. Similarly, in the previous case, from the accepting state of M1, that is my Q1, M1, the accepting state is Q1, M2, the accepting state is P1. What we did? From the accepting state of M1, which was Q1, we have defined a null transition to the initial state of M2, and the accepting state of M1 is no longer an accepting state. That change we have done. So that is my L1. For L1 accepting, we have M1. For accepting L2, we have M2, and we have put a null transition, and we have removed all accepting states of M1. And that's proposed to accept the concatenation of two languages. Similarly, in the second case, we did a new initial state, Q0, P0, they are no longer initial states. From this new initial state, not labeled, we have defined a null transition to Q0. We also defined a null transition to P0. No change in any of the accepting states. Those accepting states, they remain as they were. So this is what is called NFA null. This is a version of NFA which is known as NFA null. In some other literature, you can find word like NFA epsilon. Either there is a epsilon, or we will call this NFA null. NFA null, NFA epsilon. These are two terms. So this is version of NFA called NFA null for accepting concatenation and union. And our process of constructing NFA for accepting a language such as L1 L2 or L1 union L2, that has become further simplified. I don't need to do any kind of analysis, find out the strings that should be there in L1 L2, the strings that should not be there. I just put a null transition between M1 and M2. That's it. And of course, remove the accepting state of M1. And similarly, I just add a state, new initial state, define a null transition to the initial state of M1, M2 respectively, no change. And that will accept M1, that will accept L1 union L2. So this is called NFA null. These are NFA nulls are more general than NFAs, as they are allowed to make transitions not only on input symbols from the alphabet, but also on null inputs. So here we have defined null transitions. No input is consumed. Between this unlabeled state and Q0, no input is consumed. Similarly, between Q1 to P0, no input is required. So that is NFA null is a generalization of NFA. And here is the definition. NFA nulls are more general than NFAs, as they are allowed to make transitions not only on input symbols, but also on null inputs. So more generalized version of NFA is NFA null. Now the process of constructing NFA for a given language becomes simplified by permitting these null transitions. And here is the formal definition for NFA null, almost same as NFA, just a small change. Here is the change. That is in the state transition function delta. NFA null, like NFA, 5 tuple, same notations for the tuples, only change is in the delta. Delta is still there, only changes in its type. Now instead of Q cross sigma to 2 raised to Q, it becomes Q cross sigma union null. Null is not an input alphabet. So we say sigma union null. Q, in the case of NFA, the type of delta is, it's a mapping from Q cross sigma to the 2 raised to Q to the power set of Q. Whereas here, it is Q cross sigma union null to power set of Q. Only change is that much. Otherwise, no change. Otherwise, there is no change. Same definition of NFA null, that of NFA. No change in that. Very minor changes here, including null. So it's our generalized version of NFA called NFA null. To this point, is that clear? Is that fine? Priyank, okay, Keval, fine. Urjit, okay. Few more feedback. Okay, Ambangini, fine. Now, let us go to the next part. Non-recursive definition of delta star for NFA null. It is similar to NFA, so we don't discuss that. Let us define a term called null closure of a set of states. Let us define null closure of a set of states. So M is our NFA null. Q sigma, Q0, A, delta, these are the tuples, user meanings. M is our NFA null. And let S be any subset of Q. Q is a finite set of states, and S is our subset of Q. Let S be any subset of Q. The term null closure of S, denoted as null S, defined like this. Okay. Every element of S is an element of null S. So we are defining what is called null closure of a set of states. Meaning of null closure of a set of state is using null transitions, which are the states that can be visited from the given set of states. That is null closure. Here is the recursive definition. Here is the mathematical recursive definition for null closure of the set of states. Which are the states that can be visited from the given set of states using null transitions? That is the descriptive meaning for this. Definition is like this. Every element of S is element of null closure of S. And for any Q belonging to null closure of S, every element of delta Q null is in delta S. So we are finding basically for a given set of states, which are the other states that can also be visited using null transition. And as per the definition, whichever states are there in null S are whichever states that are there in S are there in null S. So I'm given a set of states. I am finding null closure of S. So original elements of S are there in the set null closure of S. That is step number 1. Every element of S is an element of null closure of S. And from these elements, null closure of S, now I am finding out, I am applying null transition. I am applying delta function. So all the elements of delta Q comma null, every element of delta Q comma null, Q belongs to null closure of S. They are there in null S. Suppose I am having states ABC, and from this, say from these states ABC, from A on null I can go to state P. Then from B on null I can go to state Q. And from C on null I can go to R. So my answer, null closure of ABC, null closure of a set of states. So this, in this example, my set of state is containing the elements ABC. These are the elements in S. I want to find out null of S. So as per the figure transition diagram, from A on null I can go to P. Assumption. Suppose we can go from A to P on null, from B to R on null, from C to R, PQR. ABC on null, PQR. A to P, B to Q, and C to R on null. Then my null closure of ABC will be ABC itself as per rule number 1. And from every element of this ABC, which are the states I can visit on null? That is delta Q null, where Q belongs to null closure of S. So my Q in these examples will be ABC, and from A on null I can go to P, D on null I can go to Q, C on null I can go to R. So answer will be ABC, PQR. So that's the definition of null closure. Which are the states which I can visit from the given set of states using null transitions? And this is the definition of null closure of a set of states. Is the definition clear? Is that clear? Priyank, Devansh, Keval. Okay, Ujit. Fine. So why we define this? Because we are going to use in the recursive definition of delta star for an NFA null. Earlier we had defined delta star for NFA. We had defined delta star for NFA. Now we are going to define delta star for NFA null. And here is the definition. When we say delta star, then we know it is a mapping from Q cross sigma star to 2 raised to Q. It takes a state, that is Q. Sigma star means string, and on processing the symbols of the input string, it can go to multiple states. So it is 2 raised to Q. So type of delta star, it is Q cross sigma star to 2 raised to Q. Type of sigma, type of delta is Q cross sigma union null to 2 raised to Q. Type of delta star, it is Q cross sigma star to 2 raised to Q. For a state string, which are the states that can be visited? So that is 2 raised to Q. Whereas here, when we don't apply star to delta, that is only delta, plain delta, and it is a state and a symbol, or maybe null. We find out the different states that can be visited. So from a state, such as, say, state such as A, and my symbol could be small b. From A on B, which are the states I can visit? It could be multiple states, because we are talking about non-deterministic finite automata. So it is 2 raised to Q. We have a subset, we have a set of states. And I can also make a transition in NFNL using null. So it is sigma union null. So that is the type of delta function. The type of delta star is Q cross sigma star to 2 raised to Q. And here is the definition of delta star for NFA null. Delta star Q null. Delta star Q null is null closure of Q. That is rule number 1. Delta star Q null, that is null closure of Q. where Q belongs to capital Q. Q is a state. Q is a state. From a state on null, which are the different states I can visit? So my answer will be Q itself. And from that particular Q state, suppose I have transitions on small a and small b to the state R and S, then my answer will be the state Q plus R and S. And how do I find out this QRS as answer? Take null closure of Q. My null closure of Q will be Q itself. And from that particular state, whichever null transitions have been defined, I'll add to that. So delta star Q null is null closure of Q. That is rule number 1. What will be my delta star QYA? Can anyone answer this? My rule number 2, like the definition of delta star for NFA. It is delta star small q, comma YA, where Q belongs to capital Q, Y belongs to sigma star, A belongs to sigma. So from a state small q, I want to find out the states that can be visited for the string YA. Y belongs to sigma star, A belongs to sigma. So what will be my delta star small q, comma YA? How do we define that? Just to recollect, in the case of normal NFA, it is union of R belongs to delta star QY, delta RA. In the case of normal NFA, rule number 1 is what? Delta star Q null is the set Q. Rule number 2, delta star QYA, that is equal to union of R belongs to delta star QY, delta RA. What should be the definition here? Rule number 2 for delta star NFA null. What should be rule number 2? Someone can unmute and answer, no issue with that. If you want to answer, you may unmute and answer. My rule number 2. Is there any change in rule number 2 when we define delta star for NFA null? See, basically, what are we trying to do? We want to capture the impact of null transitions. That's it. Include null, otherwise same. Yeah. Priyank? Absolutely fine. Yeah, we want to capture the impact of null transitions. So that becomes null closure of whatever we had written for NFA. Union of R belongs to delta star QY, delta RA. So whatever answer is there, using this union of R belongs to delta star QY, delta RA, that set of states will be there. Plus, whichever states we can visit using null closure, using null transitions should be included. Therefore, it is null closure of this. And that's the reason we started with defining what is called null closure. Why we defined the term null closure? Because of that. To capture the impact of null transitions. To capture the impact of null transition, we have defined the set null closure of S. And here, when we want to find out delta star for NFA null, we have to capture the impact of null transitions. Very simple example we take. Suppose I want to find out which state which I can visit from capital P. Once, for example, say A, small a. And my transition is something like this. My transition diagram is something like that. Capital P, small a, I can go to capital Q. And then I have something like from Q on null, I can go to R. From R on null, I can go to S, for example. Then my null closure of this Q, it will be Q itself, and whichever states I can go to, because I want to find out which states I can visit on small a. So P to Q on A. So my answer will be Q plus, without having any input symbol, I can also go to R, null transition. So my next answer will be R. From R on null, I can go to S. So my answer will also include S. So from P on A, I can go to Q state. No more symbol required. I can go to R state. No more symbol required. S state. So answer will be Q, R, comma S. So we have to, basically we need to capture the impact of null transitions, because no inputs are required and I can visit new states. So in order to capture the impact of null transition, we have defined the term what is called null closure of a set of states. Null closure of a set of states. Whatever elements are there in S are there in null S. Plus, whichever state we can visit using null transition. When we say states that can be visited using null transition, we have to write in terms of delta. So delta Q comma null. So whichever states we can visit from Q on null, they are also included in null S. So that is rule number 2 in null closure. Now, when I say I want to find out, I want to define delta star for NFA null. So from the string YA, all the states that I can visit, they will be there, plus in between or afterwards, whichever null transitions are there in the states I can visit, those states are also required to be added. Therefore, we are saying it is null closure of the given expression. So that is rule number 2. And similarly, the normal NFA, delta star Q null is set Q. So only one answer Q. But here, from that state Q, suppose on null I can go to R, then Q plus R will be my answer. And how to get QR as the answer? Take null closure of Q. From Q, on null, whichever states can be visited, include them. So instead of plain bracket Q, here rule number 1 is null closure of Q. Similarly, instead of plain this union of R belongs to delta star Qi delta Ra, here it is null closure of that expression. That is my rule number 2. So that is the definition of delta star for NFA null. Any doubt? Is it clear? Priyank, that's fine. Urjit, cable. Okay. Any doubt to anyone? Okay. Now, what should be the condition for acceptance of strings? What should be the condition for acceptance of a string? A string X is accepted by NFA null M, provided, what should be the condition? What is the condition for acceptance of a string in the case of NFA, normal NFA? X belongs to sigma star is accepted by NFA if, what is that condition? See, this is a mathematical subject. You need to think about this. We are not just working out examples. We are learning to write a given definition mathematically. We are learning to write how to prove it. So please apply your brain. Just don't sit idle. Don't sit idle. Just a simple example I'll give. See, when you write your LOR, most of the students write that without your presence, I could not have conducted the class smoothly. Attending, and then you are claiming that it was because of only you I could conduct the class. It was because of only you other peers could understand the content of the subject. So don't tell that much lie. Try to attend it. Try to learn it. Whenever there is something challenging, don't move away. Don't stay away. And if you are doing it, fine. That's all. Don't lie. Don't make me tell lie in my statement. Don't claim when you propose LOR, when you give draft LOR copy to me, don't say that I could not have conducted the class if you were not present. I'm easily able to conduct class in your absence. Please understand this. I don't like telling lie. Keval, what are you saying? So how do we mathematically represent that, Keval? What is, I mean, we already have studied that, very simple. Condition for, yeah, all transition final state should be element of accepting state. So how do we mathematically represent that, Keval?
Sir, intersections of the transition with the accepting state should not be equal. Oh, sorry, should not be null.
Okay, and how do we say, I mean, intersection, we are taking intersection with A, accepting state.
Yes. Yes.
So which state we are taking?
Sir, transition delta of input and let's say the delta star of Q and the given input.
Okay, now when we are saying NFA M, it means those notations have usual meanings. M equal to Q sigma Q0 delta A. So what precisely we write? Where do we start processing? From which state we start processing? Always processing begins in which state? My NFA M equal to Q sigma Q0. So we have to, my answer is in terms of Q0. And we are talking about acceptance of X, which is a string. So it is not a single symbol. X is a string. So we don't say delta. What we say? When multiple steps are there, it is delta. Is it delta Q0X or something else Q0X?
Delta star Q0X.
Delta star Q0X, exactly. So the set delta star Q0X, because ultimately that is going to be have some states. It is a set of states. Delta star Q0X intersection A not equal to 5. That is the condition for acceptance of a string in NFA that we have previously learned. Now, what should be condition over here for the acceptance of a string X belongs to sigma star? What should be the condition? Same condition, no change. Same condition. String is accepted by M if delta star Q0X intersection A not equal to 5. Not equal to 5. Is it okay? Is this fine? Okay. Please note that we cannot write conditions such as null closure of A. Instead of A, can we write null closure of A? Is it possible to write null closure of A instead of A? Delta star Q0X intersection null closure of A is not equal to 5. Can we write this? Can we change this condition to null closure of A? Because this is the condition for acceptance of a string in the case of NFA. For NFA null, can we write this? Null delta star Q0X intersection null closure of A is not equal to 5. Is it possible? Is it required? Can anyone answer this? Priyank or Keval? Not required. Not required. In fact, we cannot write that. That will be wrong. That will be wrong. We can't write this. We can't write null closure of A. Can anyone justify this? Why can't we write null closure of A? Anyone? Why can't we write null closure of A? Why it's wrong? See, because null clausure of A could contain non-accepting states. Exactly. Vimal, exactly. Null clausure of A could contain non-accepting state. So if delta star Q0x does not contain any accepting state, and if I write null clausure of A, which also contains non-accepting state, then I'll end up in non-accepting state, still I will accept a string. Therefore, we can't write that. No change in the condition. No change. Vimal, absolutely fine. So this is the condition for acceptance of a string in NFA null. Same. NFA null, NFA. In both the cases, condition is same, and we can't write null clausure of A. Here, in the definition for delta star, in both the cases, in both the rules, we have written null clausure of Q. We also wrote null clausure of the given expression. Both the rules we have applied null clausure. Condition for acceptance of a string, we can't write null clausure of A. That will be wrong. Is that fine, Vimal? Okay. Vimal, what's your CPI till the current semester? I mean, till the previous semester? What's your CPI? What's your CPI, Vimal? 9.1. Okay, fine. What about Priyank? What's your CPI? Priyank and Keval? Priyank is 9. Keval? 9.6. Fine. Please, other students also participate. You learn. You learn to learn. Then only you claim that you made the class interactive. If you are planning for higher studies particularly, then only claim that you made the class interactive and you helped yours. You also helped me in conducting the lecture. Don't overclaim if you are just a silent listener. And I don't know whether you are attending or not also. Whatever. Fine. Let's move further. Let's take this. We have defined this delta star. Closure of delta, that is delta star, we have defined recursively for NFA null. Prior we have defined that for NFA. In the case of NFA null, we have null closure applied to the right hand side of equality. Same expression otherwise. Now take an example. Impact, how we capture the impact of null transitions. This is my NFA null. And obviously this is NFA null because I have null transitions. I have null transitions. Can an FA be NFA? Can we consider FA to be an NFA? Can we consider an FA to be an NFA? Can we consider an FA? Yes, Priyank. Yes, FA is an NFA. I mean, it's not compulsory to have multiple transitions. So we can always view FA to be an NFA, whereas an NFA may or may not be, an NFA may or may not be an FA. Exactly one transition is defined for every input symbol. Reverse may not be true. Yeah, it's not always true. May or may not be. So if exactly one transition is defined, then it is FA. In NFA, same. Or if multiple transitions are defined or no transition is defined, then NFA is not NFA. Similarly, NFA null may or may not be NFA. In FA, finite automata, DFA, that is DFA, can always be considered as NFA or NFA null. Reverse may or may not be true. It's not always true. Rightly said, Keval. Fine. So we want to find out, let's see what we have computed here. We want to find out delta star Q0, 0, 1, 0. That is to be computed. We need to compute delta star Q0, 0, 1, 0. Delta star Q0, 0, 1, 0. This is rule number 2 comes into picture. Rule number 2. delta star Q0 0 1 0. So for the string 0 1 0, my Y is 0 1. The next 0 is A. This is, let us go to the bottom. We are computing this delta star Q0 0 1 0. So that is null closure of union of. Now instead of R, I'm using a different symbol Z. So Z belongs to delta star Q0 0 1 and then delta Z 0. So my input 0 1 0, it is bifurcated as 0 1, that is Y, and 0, that is my A. And that is null closure of union of Z belongs to delta star Q0 Y, then delta Z 0. So we require to compute delta star Q0 0 1. Below part, last line, we need to compute delta star Q0 0 1. To compute 0 1 0, delta star 0 1 0, I need delta star 0 1. So we go to delta star 0 1. Again, we divide this into my 0 1 string into two parts, a string that is 0, a symbol that is 1. So we always divide my input into two parts, a string containing everything except the last symbol. So here in 0 1, my string is 0 and the last symbol is 1. So that is Z belongs to delta star Q0 0, delta Z 1. String is 0 and then last symbol is 1. So there we apply delta. Previously we had 0 1 0. So my string is 0 1. So we apply delta star there. Last symbol is 0. There we apply delta. We need to compute delta star Q0 0 1. So here we are trying to compute delta star Q0 0 1. Again, rule number 2. Again, we need to find out delta star Q0 0. So we move further backward. We need to compute delta star Q0 0. Again, my 0, I'm splitting into two parts, a string and the last symbol is 0. So obviously in the string part is null. My total string, I'm divided into two parts. One part is a string, partial string, and the last part is a symbol. So that symbol is 0, the string is null. So Z belongs to delta star Q0 null, delta Z 0. So I need to compute delta star Q0 null. So further, moving further backward, delta star Q0 null is required. And when it is Q0 null, my rule number 1 comes into picture. That is my terminating condition for the given recursive definition. Delta star Q0 null. That is null closure of Q. So here it is null closure of Q0. Null closure of Q0. Already we have computed null closure. Null closure of a set of states, that will be all the elements of the given set of states plus whichever states we can visit on null transition that we had previously defined, that we had earlier defined. Yes. All the elements of S are there in null S, and whichever states we can visit on null transition from elements of null S. So here, null closure of Q0. So my first answer is Q0. And from Q0, which are the states I can visit on null? That will be P and that will be T. So rightly said, Keval, Q0 PT. It is Q0 PT. Priyank, Q0 will also be there. Q0 will also be there. All the elements of S are there. Yeah. So answer is Q0 PT. Null closure of Q0, my first answer is Q0. That is rule number 1. And the second answer, from every element of this set, instantly there is a single element in this set. The element is only Q0. So which are the states I can visit on null? So from Q0 on null, I can go to P. So my next answer is P. From Q0 on null, I can go to T. My next answer is T. And so final answer is Q0 PT. Because from P on null, I cannot go to any state. From T on null, I cannot visit any state further. So that stops. My answer is Q0 PT. So I put that expression. I want to find out delta star Q0 0 1 0. Again, 0 1 0, I need to find out delta star Q0 0 1 0. I am computing. For computing delta star Q0 0 1 0, I need to find out delta star Q0 0 1 I need to find out, for finding out delta star Q001, I need to find out delta star Q00. I need to find out delta star Q00. And to find delta star Q00, I need to find delta star Q0 null. So here I was finding delta star Q0 null, which I have found. Now I'll put these values in the bottom part. I'll put that value in the bottom part. That belongs to those values, Q0, PT. So value of my Z, it is Q0, then P, then T, and I am applying union. And in the outer side, I'll apply null closure. So before null closure, I have to apply union. It is null closure of union. So within bracket, it is union. So values of Z will be Q0, then P, then T. So it will be something like delta Q00 union, delta P0 union, delta T0. Delta Q00 union, delta P0 union, delta T0. That outer side is null closure. Now we are working on the inner side. So it is delta Q00, delta P0, delta T0, Q0 PT on 0. Let's find out that. Q0 on 0, there is no defined transition. So that is phi. Q0 on 0, that is phi. P on 0, answer is P. And T on 0, the answer is U. So that will, those values will put. That is phi, union P, union U. Q0 P T on 0. Once again. Q0 PT on 0. So from Q0 on 0, no transition is defined. So answer is phi. T on 0, answer is P. T on 0, answer is U. So it is P and U. It is phi, union P, union U. So that is what we write. That is what we write. Phi, union P, union U. So answer is PU. And then outer side we have null closure. So null closure of PU. My first answer, now I have to compute null closure of PU. My first answer is PU itself. That is rule number 1. PU itself. Now from P and U, I'll see if there is null transition. Let's see. P and U. From P, no null transition. From U, no null transitions. Correct, Cable. No null. So only answer remains PU. Only answer remains PU. Answer is PU. So I have found out delta star Q00. Everyone with the class so far? Any doubt to anyone? Priyank is fine. Keval is fine. Devansh, okay. Okay, so we continue. Delta star Q00 we have found out. Next, we want to find out delta star Q001. Delta star Q001. Here I need delta star Q00. Therefore, I have computed delta star Q00. Delta star Q00 computed to be PU. Computed to be PU. I put those values. It is set P comma U. So I put values of P and U for Z. So that is delta P1 union delta U1. Z belongs to the set delta star Q00. The value is set PU. So values of Z are P and then U. In between there is a union operator and then null closure of everything. So that is delta P1 union delta U1. Values of Z are P and U. My previous answer is set PU. So values of Z are P and U. So that is delta P1 union delta U1. And then outside we have null closure. So again, delta P1, delta U1. P1, U1. P1 answer is R. U1, that is phi, R and phi. Very rightly said Devansh. Correct, Keval. R and phi. In the union answer is R. Union of R and phi. The answer is R. Correct. Correct, Priyank. So, union of R and phi, the answer is R. And then null closure of R. Null closure of R, my first answer is R. And then let us go back to R. In the diagram from R, can I visit states using null transition? Answer is no. Is no transition defined? No. Correct. So my answer remains only R. Null closure of R, answer is R. So I have computed delta star Q01, delta star Q001, answer is R. Now I go to delta star Q0010. Here I need delta star Q001. In the bottom part, Z belongs to delta star Q001. Delta star Q001 computed to be the set R. So now Z has only one value, that is R. Z equal to R. So that becomes delta R0, null closure of delta R0. Because we are using in our diagram we have state named R. There is a state labeled R. Because there is a state labeled R, instead of, in the original definition we were using symbol R. Here we are using a different symbol. We are saying Z, because R itself is a state. Just to avoid confusion, we have used a different symbol, and that is Z. Fine. So we return to that delta star Q001. Null closure of delta star Q01. Answer was R. So we put Z belongs to set R. So there is a single element. So Z equal to R. So instead of Z, we write R. So it is null closure of delta of R0. So delta R0, we go to delta R0. R on 0. R on 0, only one transition, that is S. That is S. Yes, rightly said Devanshu, rightly said Priyank, very right cable. Answer is S. So ultimately that is reduced to null closure of S. In null closure of S, my first answer is S. This answer is S. So that is null closure of S. In null closure of S, as per rule number 1 in the definition, my first element is S. Let's go back to the diagram. So here your null closure will be clear. Exactly what is meaning of null closure will be clear now. So null closure of S, my first answer is S. Let me look at the picture. From S on null, I can go to W. So my next answer is W. So that is S comma W. Again, I have to see every element of this. Yeah. Rightly said Priyank, it is W. Now I have to see W. Now in the picture, from W on null, I can go to Q0 also. From W on null, I can go to Q0 also. So we are computing null closure of S. My first element is S. All the elements of S are there in null closure of S. That is rule number 1. So here, null closure of S, my first answer is S. Then from every element of this, I see for every element of null closure of S, I look at delta Q comma null. So transition from every element of null closure of S on null. That was the meaning actually. Symbolically, it might look little different, but it's very simple. For every element Q of null closure of S, what I have to see? I have to see delta Q comma null, and I have to include that. I have to see a transition from Q on null. So because I'm talking about transition, I have to use the word delta. I have to use the symbol delta. So what is that? In simple terms, what is that? From S, after S on null, so I'm having delta S null. Delta S null, answer is W. So my current answer is S comma W. Once again, I have to check delta W null. Answer is Q0. So I'm adding Q0 also. So answer is S comma W comma Q0, rightly said cable. Then I further look at the picture. From Q0 on null, I can visit states P and T both. P and T both, Devansh. So yeah, next comes P and T. So it is S, W, Q0, P and T. All of them are added. Now new states are P and T. Let me check if I have null transition from P or T. No null transition from P. No null transition from T. So my final answer becomes S, W, Q0, P, T. That is my null closure of S. Basically, we are capturing the null transition impact in the definition of a term called null closure of a set of states. And because this is NFN null, we have to capture impact of null transition. For example, from S11, I can go to S. No more symbol is required. So from S11, I can go to W also. I can go to P0. I can go to P. I can go to T. So delta S1 or delta star S1, delta star S1, answer will be S, then W, then Q0, then P, then T. I have to capture impact of null transitions. Therefore, we have defined the term delta star for NFA null in terms of null closure. We need to capture impact of null transitions. So it's not plain union of R belongs to delta star QI, delta array, but it is null closure of that. Similarly, that was rule number 1. It is null closure of Q. And we are capturing the impact of null transition in the definition of what is called null closure of a set of states. Here in rule number 2, we are including all null transition, delta Q null. And that we exactly did in our example. We found out delta star Q0, 0, 1, 0. And those null transition impact were captured, added the states W, Q0, PT when he computed null closure of S. So my final answer is S, W, Q0, PT. That is delta star Q0, 0, 1, 0. Is that fine? Using the definition we computed. Is that clear? Is that clear to all? Anyone has a doubt? Kaushal Chovatia, fine. Janil Patel, fine. Vimal, fine. Chandresh Gohel, okay, okay. Evans, fine. Okay, so with that we complete today's session and we'll continue from this point in the next lecture. We'll continue is converting NFA null to NFA. We converted NFA to FA based on a theorem, that is theorem 4.1, and we worked out 2 examples. Next, we can convert any NFA null to NFA. So we'll take examples, and again, we need a theorem. It is important to prove a given statement. Here you should find it interesting. Don't avoid the proofs. Proofs are important. We are learning proofs. It's not only working out examples. Important thing, that is proof. Valid arguments are important. Okay, we stop here.